What's mysterious about this instance is that the discovery was hidden from the interested public all over the world. The secret meteor. The year is 2014, when the sky over Papua New Guinea briefly begins to glow. At that time, on January 8th, an object entered the Earth's atmosphere at an insane speed and subsequently burned up. Before that, the cosmic projectile had moved through space at a speed of more than 120,000 miles per hour, a really impressive speed, clearly exceeding the average speed of classic meteorites spinning past our domestic solar system. It was this extraordinary speed that provided the experts with a revealing insight into the origin of the meteorite. In a study conducted in 2019, experts concluded that the compact meteor, just under 2 feet in diameter, was 99% likely to have originated outside the solar system. It was possibly a structure that came from the deepest reaches of an alien planetary system. There's a thesis that the meteor originated in the dense disk of the Milky Way. Despite these remarkable findings and theories, however, the results of the scientific study were meticulously kept under wraps for a long time. The fact that we are only now learning about this exciting discovery is primarily due to the fact that some of the data needed to verify the calculations were classified as top secret by the US government. Since the interstellar trajectory of the object is now considered confirmed, it retroactively advances to become the first interstellar structure ever detected in our solar system. This title previously belonged to the object, Oumuamua, which has posed great mysteries to researchers since its discovery in October 2017, but more on that later. Amir Siraj, a theoretical astrophysicist at the renowned Harvard University and lead author of the study, now intends to publish the results of his work in a timely manner. This will make it possible for the international scientific community to extend the analyses. Since the meteor burned up over the South Pacific at the time, it's conceivable that some of its fragments landed in the sea. It's therefore possible that some fragments of the galactic projectile still lie dormant at the bottom of the ocean, waiting to be tracked down and studied. Although recovering this interstellar debris is like the proverbial search for a needle in a haystack, Siraj is already in intensive talks with other experts to discuss just such an expedition. Flying mystery. Before the true background on the origin of the 2014 meteor was revealed, Oumuamua was considered the first object observed within the solar system to be classified as interstellar. The groundbreaking discovery of the craft was made possible with the help of the Pan-STARRS telescope in Hawaii, where it was added to the star charts on October 19, 2017. However, by the time experts became aware of the existence of the unusual entity, it was already on its way back to interstellar space. Once again, astronomers describe interstellar objects as those bodies that are located in interstellar space, or in other words, the space far from a star, and are not gravitationally bound to a particular parent star. However, the objects in question may temporarily pass near a star during their journey through space. After scientists learned of the existence of our interstellar visitor, it raised a fundamental question. What exactly is Oumuamua all about? The first analysis of its orbital properties suggested that we are dealing with a classic comet. However, it wasn't long before this initial hypothesis was thrown into doubt, because Oumuamua does not have a characteristic tail. What we do know is that the object described the apex of its orbit on September 9, 2017. At that very moment, the structure was temporarily moving around the sun at over 50 miles per second, approaching within about 20 million miles of our central host star. A little over a month later, Oumuamua then went head-to-toe with our blue home planet when it passed Earth at a closest distance of about 15 million miles. Since then, the interstellar body has been on course for the constellation Pegasus. In addition to all these objective findings about the trajectory of the object, there were also some unexpected observations, things researchers still cannot explain exactly. Among them, for example, is the fact that Oumuamua slowed down somewhat less after its solar passage than the experts had predicted. This circumstance cannot be explained by the pure influence of gravity. At first, it was speculated that the additional acceleration could be attributed to the outgassing of volatile components. Such an outgassing, caused by the proximity to the sun, would have led in all probability to a drastic change of rotation. In fact, however, this was not detected. To gain further insight into the characteristics of this flying mystery, Oumuamua was observed by numerous modern telescopes. During the analyses, it became clear that the object undergoes dramatic fluctuations in brightness, a characteristic that suggests that the structure has the shape of an oversized cigar. However, the analysis of the photometric data collected was not sufficient to explain the unusually strong brightness fluctuations with a corresponding rotation speed. Thus, it seems that Oumuamua does not rotate around one of its main axes during its flight, but rather staggers through space. It's likely the object already showed this motion pattern when it left its home system. All these unexpected observations and characteristics finally led to a central question. Is it possible that Oumuamua has no natural origin, but was artificially created? An alien spacecraft? This controversial speculation was also fueled by the fact that no dust particles could be identified in the immediate vicinity of the ominous body. This in turn leads to the assumption that Oumuamua does not contain any water and possibly consists entirely of metal. Since the surface of the object was exposed to an incessant bombardment of cosmic rays during its billion-year journey, the experts assume a comparatively low reflectivity. Assuming that the albedo is 0.04, the mean diameter of the missile would be about 700 feet. In November 2018, astrophysicists Avi Loeb and Shmuel Bialy hit the headlines when they tried to justify the absence of dust and orbital deviation with an unconventional hypothesis. Thus, the corresponding observations could well be explained by an extremely thin, large surface area body that was deflected from its ancestral orbit under the influence of the sun's radiation pressure. Possibly, so the two Israeli experts think, Oumuamua is an extraterrestrial solar sail sent by an intelligent civilization to research our solar system. An unusual assumption, which was not categorically rejected by other researchers. In fact, in December 2017, some researchers decided to take a closer look at Oumuamua as part of the Breakthrough Listen research project. To this end, the entity was analyzed by the radio telescope at the Green Bank Observatory in West Virginia. The goal of this endeavor was to register possible signals of artificial origin. Although it was considered extremely unlikely that we'd encounter radio signatures of an extraterrestrial species in the run-up to the work, the scientists nevertheless saw the investigation of Oumuamua as a worthwhile, unique opportunity. Over a period of 14 days, the interstellar object was analyzed in different frequency ranges. However, the evaluation brought the sobering realization that no evidence of an artificial background could be found. Future investigations. To reveal the true background of our mysterious visitor, a direct investigation seems most promising. But how do you intercept a craft traveling away from us at more than 15 miles per second? It would be virtually impossible for conventional space probes to reach Oumuamua. In order to get to the bottom of this exciting mystery one day, new approaches would have to be taken. One such concept is based on a literally explosive approach. An unmanned spacecraft could be ejected from our solar system by igniting a solid fuel engine. Once such technology is fully developed, it would be possible to reach Oumuamua within 16 years of the launch of the terrestrial spacecraft. However, patience will be required before this can happen. Those who do not believe in an artificial origin of the object sometimes suspect that it could be the fragment of a Pluto-like exoplanet. According to this view, Oumuamua would consist mainly of frozen nitrogen. However, the interstellar structure would have already lost most of its original mass. During its journey, large parts of the nitrogen ice melted so that the once clearly more massive body took on